Okay, coming to the uh, types. So this is a lecture video series about the stepper motor, and then this is the second video of continuous second video of the series. So in previous session we are going to we have discussed about what is stepper motor, what is the principle of stepper motor. In this video we are going to discuss about the types of stepper motors. The types of stepper motor is variable reluctance stepper motor, permanent magnet stepper motor, and hybrid stepper motor. Again, variable reluctance motor classified into two types, that is single stack variables reluctance motor, multi-stack variable reluctance motor. And then permanent magnet stepper motor, that is PM stepper motor have rotors that are constructed with permanent magnet which interact the electromagnets of the stator to create a rotation and torque. The permanent magnet stepper usually have comparatively low power requirements and can produce more torque per unit in input power. But coming to the variable reluctance motor, that is VR or switch reluctance motor, are built with permanent magnets. Rather, they are constructed with plain iron and reusable gear with the protrusions or teeth around the circumference of the rotor. The teeth leads to VR stepper that have a very high degree of angular resolution. However, this accurately using comes at the expense of torque. And then coming to the hybrid synchronous stepper motor, HS stepper motor, rotor uses the best features of both PM and VR steppers. The rotor in the hybrid stepper motor, synchronous stepper motor, has permanent magnet core, while the circumference is built from the plain iron and has teeth. Teeth is nothing but the slots or tooth of the stator. The hybrid synchronous motor therefore has the both high angular resolution and high torque. And then what is step angle? So step angle is defined as the angle that which the rotor of the stepper motor moves when one pulse is applied to the input stator. For example, the full rotation is 360 degree. It was classified into 60 angle. So for we need to give the 60 pulse to the motor for motor operations. The position of the motor is decided by this step angle and is expressed in degrees. The resolutions or the step number of motor is the number of steps it makes one revolutions of the rotor. The smaller the step angle, the higher the resolution of the positions of the stepper motor. The accuracy of the position of the objects by the motor depends on the resolution. The higher the resolutions, greater will be accuracy. A standard motor will have a step angle of 1.8 degree with 200 steps per revolutions. The various step angles like 90, 45 and 15 degrees are common in simple stepper motors. This is a step calculations. So pi equal to ns, and ns is nothing but the synchronous speed minus nr divided by ns into nr into 360 degree. So pi equal to step angle, ns equal to number of teeth on stator, nr equal to number of teeth on rotor. Steps per second equal to rpm into pi into 60. This is the simple step calculation of the stepper motors. And then stepping modes, we have two stepping modes. One is full step modes and then half stepping modes. What is mean with full step? The standard hybrid stepping motor have 200 rotor teeth or 200 full steps per revolutions of the motor shaft. Dividing the 200 steps into the 360 degree of rotations equal a 1.8 degree full step angle. Normally full step mode is achieved by energizing both windings while reversing the current alternatively. The half step simply means that the step motor is rotating at 400 steps per revolution. In this mode, one winding is energized and then two windings are energized alternatively, causing the rotor to rotate the half of the distance or 0.9 degree. So although it provides the approximate 30% less torque, and half step mode produces the smoother motion than the full step mode. So and then micro steps. So stepping mode having these kind of micro steps. The one is full step, off step, and then micro step. What is micro stepping? Micro stepping is the relatively new step motor technology that controls the current in the motor winding to a degree that further subdivides a number of positions between poles. It is typically used in application that requires accurate position and smoother motion over a wide range of speeds, like the